These are the practice problems for Lesson 10, Introducing Graphs of Proportional Relationships. And this is problem number 1. And in this problem, you're supposed to identify which graphs could represent proportional relationships and explain how you know that. And they use the word could here because just because it looks like it's a proportional relationship, and A does look like it's a proportional relationship, doesn't mean that after you go outside of where it's graphed, it continues to be a proportional relationship. So they always qualify this with the word could or can be a proportional relationship. And so the things to look for, the graph is a straight line, and the graph goes through the origin. So it has those two things. And one other thing that you could look at is if you double the value of x, if I go from 5 to 10, does the value of y double? Does it go from 4 and it should go to 8? And in fact, it does. So if you double x, 5 to 10, you also double y. It goes from 4 to 8. Also, C is a proportional relationship. X and y are proportional. Straight line goes to the origin 0, 0. And when you double x, when x is doubled from 5 to 10, y should be doubled from 1 to 2 if it's proportional, and it is. So if you double 5 to 10, then y gets doubled from 1 to 2. So both A and C could represent proportional relationships. B and D cannot. So that's easier to say that they definitely cannot represent proportional relationships. So B is a curve, it's not a straight line. And look what happens also when you double x. If you go from 5 to 10, look what happens to y. Y goes from 2 to 8, so that's 4 times as much. So in this one example, from 5 to 10, y is 4 times as big, not double. So it's more than that. So not a proportional relationship. And D, although it's a straight line, it does not go through the origin. So this also is not a proportional relationship. So the line not through the origin, but look what happens also when you double x. When you go from 5 to 10, y is not double, it's not even anywhere close. It goes from 7 to 8. So A and C are proportional relationships, straight lines that go through the origin. B is not a proportional relationship, it's a curve, it's not a straight line. And D is not a proportional relationship, although it's a straight line, it does not go through the origin 0, 0. This is problem number 2. It says a lemonade recipe calls for 1/4 of a cup of lemon juice for every cup of water. And what does X represent and what does Y represent in this table? And you can see that from what they give, the information that's given to you, it's 1/4 of a cup of lemon juice. And so there's that 1/4 right there. So Y is going to be the cups of lemon juice. And it's for every, and you can say 1 cup of water, for every cup of water or every 1 cup of water. And there's the 1 right there. So X is going to be the cups of water. And you can read this as 1/4 of a cup of lemon juice per 1 cup of water, or lemon juice per water. And so that's y over x. And we're going to use that ratio, y over x, to figure out if there is a constant of proportionality. That's how we're going to tell whether or not this is a proportional relationship between x, which is cups of water, and y, which is cups of lemon juice. But first I'm going to change all of these fractions to fourths. You're going to see why in a moment. It's just going to be easier to work with all fourths. So 1 is 4/4, 1 1/4 is 5/4, and 1 1/2 is 1 2/4, which is also 6/4. So you take the y value and you divide it by the x value, so 1/4 divided by 1. And I'm going to take the 1/4 and I'm going to use the inverse operation, which is multiplication. I'm going to use the multiplicative inverse of 1, which is also 1, by the way. And so this is 1/4 times 1 equals 1/4. Now you could have just written it as 1/4 divided by 1 equals 1/4, but I'm going to use this same operation all the way down, so I want to be consistent. So 2/4. 2/4 divided by 2. So now I have 2 of something. And I'm going to divide that into 2 groups. So that means that 1/4, one of those things is going to go into each group. So this answer is going to be 1/4. So I'm going to use the inverse operation, which is multiplication, and I'm going to use the multiplicative inverse of 2, which is 1/2. And 2 divided by 2 is 1, so these 2's can cancel out, and you're left with 1/4. So 2/4 divided by 2 is 1/4. 3/4 divided by 3. So now I have 3 of something, 3/4, and I'm going to divide that into 3 groups. That means that 1/4 is going to go into each group. So 3/4 divided by 3 is the same as 3/4. Use the inverse operation. It's 3/4 times, and the multiplicative inverse times 1/3. 3 divided by 3 is equal to 1, so those cancel out, and you're left with 1/4. 4/4 divided by 4. This is kind of weird to write and look at, but you can just do it this way. 4/4 divided by 4, use the inverse operation, which is times multiplicative inverse times 1/4. These 4's, 4 divided by 4 is 1, so these 4's cancel out. You're left with 1/4. You could also cancel out these 4's, and you're still left with 1/4. But I want to, again, be consistent with what I've done before. 5/4 divided by 5. So now I have 5 of something. These things called fourths, and I'm going to divide those into 5 groups. So that means one of those fourths is going to go into each group. So 5/4 times, so use the inverse operation, multiplicative inverse times 1/5. These 5's, 5 divided by 5 is 1. They cancel out. You're left with 1/4. And finally, 6/4 divided by 6, the same thing. You're left with 1/4. These 6's cancel out. This is the inverse operation, multiplication, the multiplicative inverse, 1/6. Then it says graph them. So I put together this coordinate plane. So it says graph or plot the pairs. What that means is the pairs are the coordinates. It's a coordinate pair that identifies a point. So the x-coordinate is 1, the y-coordinate is 1/4. So the x-coordinate is 1, the y-coordinate is 1/4. So it identifies that point right there. So we'll go through one example. But as I graph these, the graph of these points forms a straight line that goes through the origin, goes through 0, 0. So those things suggest that this is a proportional relationship between the cups of water and the cups of lemon juice. So one example, if I use 5 as the x-coordinate, so I'm going to go out to the 5 on the x-axis. That means I'm going to go up to this point, which is 5/4. And if I go over to the y-axis, you see that that is 5/4. And to label that point right there is the coordinate pair of the x-coordinate, which is 5, and the y-coordinate, which is 5/4. You can also write this as 5 and 1 and 1/4. Same thing. You can use either one, either way to write it. So you usually look at the y-coordinate first. So you go out to the y-coordinate on the x-axis. I'm sorry, you look at the x-coordinate first. So you go out to the x-coordinate on the x-axis, and then you go up to the y-coordinate along the y-axis to either the point that you're plotting, that you're graphing, or if you're looking at the graph and you want to find out what the value of y is, you read up to the graph and then over to the y-axis. This is problem number 3. It says, decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would the constant of proportionality be? And this is the size that you can print of a photo. So the sizes you can print a photo. So if we look at y divided by x, we're going to look to see if there is a constant of proportionality. And so the first one, 3 divided by 2, is 3/2. The second one is 6 divided by 4, which simplifies also to 3/2. So this is, you can factor out the 2, 2 times 3, and you can factor out the 2 again, 2 times 2. And so those 2's, 2 divided by 2 is 1, so they cancel out, and you're left with 3/2. So up to this point, it looks like it could be a proportional relationship. This is why they use the word could right here. The table could represent a proportional relationship, because beyond this point, beyond row 2, it moves away from being proportional. There is no longer a constant of proportionality. So without the equation, they want to use the word could because you don't know what's going to happen after each row. So you label the x value and label the y values. Okay, so when you get to 7 divided by 5, 7/5, that's equal to 14/10, whereas 3/2 is the same as 15/10. So these are different. 5 times 3 is 15, 2 times 5 is 10, so 3/2 is 15/10, 7/5 is 14/10. So these are different, so it's not a constant. It's not a common factor or a constant factor. It's not a constant of proportionality. And 10/8, 10 divided by 8, simplifies to 5/4. 5/4 is the same as 1 1/4. And if I go up here to 3/2 and I change that to 1 1/2, which is the same as 1 2/4, you see that 3/2 is different than 10/8, which is 1 1/4. So there is no constant of proportionality. So let's see what happens if we graph this. So I'm going to graph each of those points. So the first one, the x-coordinate was 2, the y-coordinate was 3. So that goes up to point 2, 3. The next one goes to point 4, 6. So that looks like it's on a straight line, goes through the origin, so everything looks good up to this point. But beyond that, it goes to x is 5, y is 7, so this is 0.57. So now it's no longer a straight line. You can't draw a straight line through these 3 points. And the last point from the table is 8, 10. So the x-coordinate is 8, the y-coordinate is 10, and that further shows that it's not a straight line, so there's no constant of proportionality. So it is not a proportional relationship. So the second table is the height of a lighthouse as you move further away from that lighthouse. So they're looking at how many feet of the lighthouse you can see. So what's the height of the lighthouse? 20 feet, 45 feet, 70 feet, 95 feet, 150 feet. And the distance, you can see these different heights. How far you can go away from these lighthouses and still see them. So you can go 6 miles away, you can go 9 miles away and see a lighthouse that's this tall, 11 miles and see a lighthouse that's 70 feet tall, 13 miles, see a lighthouse that's 95 feet tall, and 16 miles, see a lighthouse that's 150 feet tall. So, is there a constant of proportionality between the distance at which you can see a lighthouse and its height? So y divided by x, 6 divided by 20, that simplifies to 3/10. 9 divided by 45, that simplifies to 2/10. It's 1/5. 1/5 is the same as 2/10. So these are not constant. So it doesn't look like there's a proportional relationship between the distance and the height of the lighthouse. 11/70ths, you can't simplify that anymore. 13/95ths, that cannot be simplified anymore. And 16/150ths simplifies to 8/75ths. So these are all pretty tough fractions to deal with. So this is a case, although I don't normally like to do this, this is a case where I would change them each to their decimal fraction equivalent. So divide y by x with a calculator, and I'm going to write this out to the hundredths place. So this is 30 hundredths, 20 hundredths, 16 hundredths, 29 hundredths, and 11 hundredths. Looks like there might be a mistake here because it goes 30, 20, 16, 11, and this, so these are all decreasing. That ratio is decreasing. This one is different. So I wonder if there's a mistake there. So you might check that. But the point is that it's not constant. So there's no constant proportionality. So the height of lighthouses that you can see is not proportional. The distance that you're away from those lighthouses is not proportional to their height. I did go back and check this calculation. It turns out that I did make a mistake on this. So 13 divided by 95 actually equals 14 hundredths, not 29 hundredths. So it's a pretty good example that even though this is not a proportional relationship, the height of a lighthouse is not proportional to the distance that you can see that lighthouse, the distance away that you can be to see that lighthouse. But there is a relationship here, and this is a relationship that you will examine, look at, learn about in later grades, and it should decrease. So 13 hundredths, 20 hundredths, 16, 14 hundredths, and 11 hundredths. Even though it's not proportional, there's still a relationship where this ratio decreases. So I did make a mistake, should be 14 hundredths, not 29 hundredths. This is problem number 4, and it asks to select all the pieces of information that tell you that the relationship between time and distance is proportional as a turtle walks away or moves away from a rock. And so there are two parts to that turtle moving away from the rock. There's the time it takes to move away from the rock, and the other part of that is how far the turtle moves in that amount of time. So are those two properties proportional in the situation? So A is the equation for that, and it does tell you that time is proportional to distance. It says y is equal to 3x. So the amount of the distance is proportionally related to the amount of time by that ratio, y over x. That ratio is 3. And what that means, that ratio is the constant of proportionality. And it means that the value for distance is 3 times the value for the time. So y is equal to 3x. B, on the other hand, isn't enough information to tell you that the relationship is proportional. There's no ratio that connects the distance to the time. You need more than one point. It's true that 12 is 3 times 4, so you could say, well, that's the ratio right there. But you need more points to give you an idea that that truly is a ratio that has a constant of proportionality. You can't just take one point and say, oh, that's the ratio, that's the relationship. It's a question of what's happening over time at several different places. Are those changes proportional? And just given one point is not enough information. C, the turtle walks for a bit, then stops for a minute before walking again. So there's no constant rate. So this is not a proportional relationship between time and distance because the turtle stops and then starts again. And D, it says the turtle walks away from the rock at a constant rate. So it tells you that it's a constant rate. That's the constant of proportionality. So that tells you that this is a proportional relationship between the amount of time it takes to travel a certain distance. So A and B give you enough information to say that it's a proportional relationship. B and C do not.